I'm Cyril Dunant, working at the University of Cambridge, and my question is, why are steel beams eye-shaped? Now, steel beams are key element typically in construction, and obviously we want construction to be light, but at the same time we want it to be strong. Now, if you imagine the beam bending, it's clear that the top is under the most compression and the bottom is under the most tension, meaning that if it's going to break, it's going to break either at the top or the bottom. And the bits in the middle are not doing much. Therefore, it has to be that we want a beam that is strong at the top, strong at the bottom, and we don't care so much what's in the middle. So clearly, the lightest solution has to be a beam that is completely empty in the middle and has only a top and a bottom. Now, clearly, that's still not going to work because we want them to be attached somehow. Thus the eye shape, with a lot of material at the top, a lot of material at the bottom, and as little as we can in the middle.
Hello, my name is Jennifer Tenner and I'm working for the Institute of Manufacturing Technology. And I will try to answer the question, what are the next steps forward in metal forming? So I think one important step forward will be to realize lubricant-free metal forming. So doing the forming without lubricants will be much better for our environment, will help us to stop pollution and waste of material. And I'm really hard working on this topic and I hope we will manage to find a good solution for that.
So I'm Paul Blackwell from the Advanced Forming Research Centre at the University of Strathclyde. And my question is, how do they make copper wires so thin? Okay, so let's think about how you make a copper wire. You'd start off with copper, which would be cast into an ingot. It would then be broken down through a forging process. It would then pass through an extrusion process that would actually convert it to a round shape, a round cylindrical shape. It would then usually be hot rolled to make the diameter progressively smaller and smaller and smaller until you reach the point where you could start to draw it. So drawing is a process where you feed the rod through a tool, a die, and pull it through and along what's called a drawing bench. And the way that you make the copper wire progressively smaller is you pass the wire through a series of successively smaller dies, and each time it gets smaller, smaller and smaller. Now, a problem is that as it's deformed, it also gets harder. So sometimes, at some stage of the process, you may need to heat the metal up to anneal it and soften it before you can progress through to the very end. But by doing that, you can take your initial ingot, which may have a diameter of, let's say, 500 millimeters, right through to a very fine wire that might have a final diameter of maybe just 1 millimeter or even less than that. And that is how they make copper wires.
Hi, I'm Jill Thornton. I work for Liberty Steel in Sheffield, and I'm working on powder metals, 3D printing, hot isostatic pressing, metal injection moulding. And first question I'm looking at is, will 3D printing of metals ever reach the precision of a machined part or a cast part? It's a really good question, and there's two answers to that. 3D printing can actually produce quite intricate parts that machining can't produce, so there are advantages of 3D printing over machining and casting. So you could have an internal void built up with the 3D printing, but then the surface finish of machine parts is much better. But we've got a process now called hybrid, which has a changeable head, and one head can do the 3D printing and one head can do the machining. So with that device, you can have the best of both worlds.
Sure. My name is Brad Kinsey. I'm from the University of New Hampshire in the United States. And my first question is, why do metals shine? Metals shine because of the surface roughness of the material. You might think that a metal looks pretty flat, but if you actually zoom down in, there'll be little craters and little mountain ranges within the material. And so what you do then is you take some material, a very fine sandpaper, if you will, and polish the material. So I'm at a conference, and one of the things that I learned is the term for that is called buffing, and it comes from buffalo skin, which is the original material they used when they were polishing metals.
Hello, my name is Sibylle Friedrich. I am the project manager of the Collaborative Research Center, a micro-cold forming from the University of Bremen. And the question is, do you have any advice for a 14-year-old girl who wants to get into science? I think that's a very good question, and the question shows that the person is interested, and the advice is I can give to be nosy and to look at the things and don't be shy to study what you want to do, and if you don't doubt to do it, then it will work.
Hello, I'm Shwan Rasul. I'm a second-year engineering student at the University of Cambridge, and someone has asked, why do metals rust? So what happens is the oxygen in the air reacts with the metal to form a different compound. For example, iron would form iron oxide with the oxygen in the air, and that's rust. Rust can be a big problem, but it can also be a solution. For example, in sacrificial galvanization, you have one element which is more reactive than another that rusts to protect the less reactive element. So, for example, you might have an iron nail which is coated in zinc. The zinc will react with the oxygen in the air, forming zinc oxide layer, which is strong and will protect the internal iron.
Hi, I'm Ramya. Actually, I'm an Indian, but I'm studying Masters in Mechanical Engineering in South Korea. So the question for today is like, how are you able to make an aluminium foil? That's all. This is kind of a simple question. It's like it's from the main ore, which is bauxite is kind of main ore, which is used to make the aluminium. We have to remove the impurities. It's like same when we drink a water, it should be pure, right? We used to boil that. Just we have to remove the impurities. Then it will have the aluminium oxide. When we heat and melt it continuously, it will form the aluminium oxide. Then the aluminium is made. When we have the aluminium, we just keep on rolling. It will make a thin sheet. That's all the aluminium foil is made.